So we are talking about atmospheric aerosols. This is very simple slide and most of us know about it. So what I want to say about here, that our atmosphere is actually like a cooking pan which cooks everything you put into it. So these, what are the ingredients we are putting? We are putting different type of primary and secondary aerosols. Primary aerosols means the particles which are coming directly from the sources, or secondary aerosol means gases are coming and then those gases are converting into aerosols. The sources, as we all know, are various pollution sources, uh, forest fire, biomass burning, vegetation which are emitting VOCs like isopropyl, etc. Sea salt which are sprayed by sea, mineral dust, windborne mineral dust we are talking about. So from whatever source, once aerosols are there in the atmosphere, then they start interacting with each other. And then they move with the winds. Wherever winds are going, these aerosols are also going. And we all know that in lower atmosphere, the resistance time of aerosol is about a week. But within this week, they can travel thousands of kilometers depending upon wind direction and speed. So what happens when they are transporting into aerosols? During long distance transport, aerosol mixing, aging, chemistry, this takes place. So what does that mean? Let us try a little bit talk about it. So this blue part is aerosol. Now it is whether it is primary or secondary. It can be organic, sea salt, metal, dust, black carbon, or anything. Then you have in the atmosphere, you also have certain humidity or liquid water content. So depending upon the hygroscopicity of this aerosol, you will attract the humidity and you will make it slightly aqueous. Once it becomes aqueous, then there can be faster diffusion of gases like VOC. VOC is volatile organic carbon, then NOx, ammonia, variety of sulfur compound, sulfurous gases. These gases react with different oxidants present in the atmosphere, like hydrogen peroxide, hydroxyl radical, ozone, nitrate radical, etc., and form variety of secondary aerosol, which can be sulfate, nitrate, secondary organic aerosol. And we all also know that things are different during daytime, different during night time, so chemistry is different. And all during this long range transport process, there are multiple multi-phase chemistry processes are taking. When I am saying multi-phase, that means it involves solid, liquid, and gas phase. So what happens? Okay. So what happens is from the emission, you may have fine or coarse particles which are externally mixed. Externally mixed means, say, suppose you have different type of flour, gram flour, wheat flour, rice flour, etc., and you make pellets of them. So these all pellets have different taste. You know that. Now once you put them in the atmosphere, and atmosphere, if it is mixing and making one bigger pellet, which is well mixed, so then original property of those particles are gone. Now they are internally mixed particles. So this atmospheric processing actually converting externally mixed particle into internally mixed particle, which changes the size, surface properties, and optical properties. It also changes the bioavailability of nutrients. So what does that mean? What are these processes? That we will see once the talk will